Okay, so we're going to talk about applications of right triangles as it pertains to either distance or height problems. So I'm going to just tell you there's no like set process for these. I know I've talked about in some other videos there's certain applications where they have like a certain flow to the problem. These types of problems, there's not a set process. You really just need to analyze the situation. So I've chosen three very different problems just to give you a different sense of flavor here. So the first one is going to use what's known as the subtense bar method. So just to tell you what that is, this is just a method used to determine a small distance, and we'll call that distance d, between 2 points P and Q. And so these ones actually are nice because they will often come with a picture. So for this first one, so you've got this situation here. And I would recommend that you copy this picture down just so that you're familiar with what it is. And then you're kind of given different conditions here. So maybe you want to pause and write all this down. Okay, so we want to find the distance d when theta is 2 degrees, 3 minutes, and 15 seconds, and b is 3.5 centimeters. And then how much change would there be in the value of d if theta measured 1 second larger? So we'll tackle both of these. Okay, so the angle theta here is being bisected, so we can use theta over 2, because what you're going to want to do here, notice that I've really got a right triangle going like this, right? So this part here is how we're going to figure out d. So even though I have all of these pieces, I really just need to focus on this little triangle. And okay, so to do that, let's just label this as theta over 2. So notice in this case then, I'm trying to figure out this distance d. I've been given theta over 2, so I have something I can plug into it, right? And then I have this b, 2, so this b over 2. So I want to find this side. I know this side, and I know this angle. So this really looks like opposite and adjacent sides, right? So this is going to be the tangent function. So I can take my tangent of now what my theta over 2 is. That's going to be my opposite over my adjacent side. So I can just plug all this stuff in. So I'm going to take my theta, which is 2 degrees, 3 minutes, and 15 seconds, and divide that by 2. The opposite side is going to be this 3.5 divided by 2, so I've plugged that in. And then remember, d is what I'm trying to solve for. So I've got all the pieces now, and what I would recommend that you do, so just leave everything in like these weird fractional forms until the last minute when you're ready to calculate. So let's go ahead and solve for d. So if I solve for d, it's really just rearranging, right? So d is going to equal now this 3.5 over 2 divided by this tangent, the whole theta divided by 2 again. So this is what I want to plug into my calculator. And so when I do that, I get 97.613. And so notice that we've got 5 significant digits here. So that's how many I have here. Okay. All right. So that was the first part. And then just how much change would there be if theta was 1 second larger? So now I'm just being asked to repeat all this work really. So I've got all of this, but now for my theta, I'm just going to add 1 second to it. So instead of being 15, it's going to be 16. So what I would recommend is that you pause the video here and just try to do this second part by yourself to make sure that you understand this. And then when you think you've got it, we'll go through the solution in detail together. So pause here. Okay, so I'm going to plug in my pieces. So it's like literally the same thing, right? So at 2 degrees, 3 minutes, now 16 seconds divided by 2, all these pieces, all the same stuff. So I can plug everything in. So I have 3.5 over 2 divided by tangent of the same calculation, right? Except now it's just 16 seconds. So what I got was 97.600. So remember your significant digits. And then remember the question is asking for how much change there would be. So change is indicating that we just need to subtract the two values. So with a 1 second increase, there's a 0.013 centimeter change. So that's just the last part there. Okay, so that one is, so that's talking about distance, right? And I just want you to kind of notice like what we did with this. So you've usually got a theta, you've got a right triangle that's going to pop up somewhere, and then you're going to have like at least one side is given. So this is kind of the flow of these, but these can get kind of challenging, and I thought it would be good to do kind of a more challenging problem. So I've got the angle of elevation is 32 degrees and 15 minutes for to a pyramid. Sorry, I forgot to write the pyramid. And this is a pyramid right here. So this white figure is a pyramid. and then the angle of elevation from a point 120 feet farther back is 20 degrees and 25 minutes. So I've got that marked here. So find the height of the pyramid. Okay, so I've marked this picture. This picture is pretty important. So I would actually recommend, once again, that you pause this, because this picture is going to really help us figure things out. So I have this angle here. I have this angle here. I know from here to here is 120 feet. And I want to find the height of the pyramid. So we have some info about these two larger triangles in relationship to H. So think of this triangle here. So see this triangle? So you've got the one formed here by this set of dotted lines. And then you have this bigger triangle coming out here, going all the way back to H and up. So this is very important that you recognize these two triangles. So this is important to note where your info is coming from, because what I'm going to be forced to do, any relationships that I set up are actually going to be in terms of these like angles of elevation, these larger triangles that you see. We're not really going to use, besides the H, we're not really using this white triangle to help us solve this. Okay, so this is tricky because we don't even have like a full side, right? I don't know, like this larger triangle here, this entire side, I don't know what it is. I know that this little piece here is 120. So this is going to be a little tricky. So since I have two larger triangles in relationship to H, this is very important. And I don't have much other information, right? I don't have anything about the sides here besides this 120. I don't know anything about H. I just know really these angle measures, but I know how they relate to H. This tells me I need to create a system. So I've just got to take the information that I've been given and I just got to run with it. So the one thing that we're going to do is I'm going to call this piece here from here to here D. Okay, so starting, and I'm going to tell you where to pause. I want you to think about this and work through this with me, okay? So let's start with the outer triangle, okay? So I have this angle here, and I have something I could plug in for this side, and I have something I could plug in for this side. So this is the information that I've really got. So which trig function is going to work here? Is it cosine, sine, tangent? Okay, so I've got this, I've got the opposite, and I've got an adjacent side. That's what I can plug in. So I want you to write down what you think we should do for the first trig function for the larger one. Okay, so it's going to be tangent of 20 degrees and 25 minutes is equal to, so the opposite side over the adjacent side. The adjacent side is found by taking this length here, D, and then this 120. So this is the first one. Okay, so this is the first equation. So remember, we're trying to set up a system. A system will have like two equations. So now moving on to the smaller triangle. So once again, I want you to take a second to pause the video and set up the second trig function here. Okay, so the second trig function is going to be 32 degrees and 15. So it's still tangent, right? And then I've got this opposite over the adjacent side. So now I've got two equations, and I want you to notice, so it is a system. I've got two equations and two variables. So from here, we can easily solve each of these for H. H is the easiest letter to solve for in this set of equations. So think back to, algebra and how systems work. So why don't you pause the video here and solve each of these for H? And I actually would challenge you to see if you can figure out the rest of this at that point. Otherwise, I'll keep walking you through this. Okay, so the first one, if I solve for H, so I just really multiplied this D plus 120 right to the other side. And then for the second one, if I solve for H, so I've got this H now is going to equal D tangent 32 degrees and 15 minutes. Okay, so this is, we're getting that direction, right? And now that I have these two H's, I can really now set these two equations equal to one another, right? So we're kind of using like the substitution method. So now I've set the two equations equal to one another. So now I'm going to work on solving for D. So first I'm going to distribute, and I just want you to notice that when I distribute, that D, I put it in front, and then the 120, I put it in front. I do that so that I don't get confused with what the trig function is, okay? All right, so continuing on, I notice now that I have a D term here and a D term here, and this term here does not have a D in it. So, and oops, I forgot my minute mark, but I replaced it here. Sorry about that. Okay, so now I have the term with no D on one side and then the two terms with D's on the other side. And this is a really classic trick that you use because obviously these are not, we can't combine these. So instead what I notice is that both of these have a d in them, so I can factor it out. So see how I've factored it out? And now I'm trying to solve for d, so I can just divide by the thing that is, you know, that I don't need. So I'm going to divide by this whole thing. So d equals this big old crazy fraction. Okay, now this is where you have to go back and maybe reread the problem or remember, like, what were we doing? Are we done? We're not done. So earlier we said that h was equal to d times tangent of 32 degrees and 15 minutes. So this d now, remember, we're trying to solve for height here. We're trying to find h. So this whole thing is what I need to plug in for d. So let's do that. So I've got d times tangent of 32 degrees and 15 minutes, and now I'm going to replace it with that whole crazy d. And you do want to leave, like, again, as I always advocate for, you want to try to leave things in fractional form until you get to the very last moment. So now I have everything, and now I can finally multiply it all together, and I just rounded to 109 feet, and so that's what that one comes out to. Okay, and I have one more question, or one more type of problem to go through. So that last one was pretty tricky. I think this one's a little more straightforward, personally. Okay, so it says in a certain area, the lowest angle of elevation of the sun in winter is 22 degrees and 15 minutes. Find the minimum distance x that a plant needing full sun can be placed from a fence 4.75 feet high. Okay, so first things first, I really want you to do this one totally on your own, so I'm going to try to walk you through it. So this is talking about what? It's talking about a plant being placed someplace away from the sun. So can you just draw what this picture looks like and label it as much as possible? So pause the video and just try to draw this picture. Again, if you get it wrong, it doesn't matter, right? It's just how you learn things. So you have to make mistakes to learn things sometimes. Okay, so I've got the fence, and it's a 4.75 feet fence, and then I've got the plant somewhere, right? It's plant sitting somewhere behind the fence. And the goal here is I've got this angle, so the sun is going to come up, and I know that the angle of elevation that the plant makes to the fence is going to be this 22 degrees and 15 minutes. So what I want is I want to figure out how do I ensure then from kind of this information that my plant can be placed at the appropriate distance. So I'm really looking for this distance here, so we'll call it x. All right, so in this one, I think you now have all the information that you need to finish this. So remember, you know what distance you're trying to find. You've got an angle measure. So I would highly recommend that you try to figure out what trig function to use and finish this one and hit play when you think you've got it. So I notice I've got this. I've got the adjacent and the opposite sides of this kind of measured out. So that's going to require me to use tangent. So tangent of 22 degrees and 15 minutes is going to be equal to the opposite over the adjacent, so 4.75 over x. Then I can solve for x, and I can just plug this into my calculator to get this whole thing. However, remember, of course, you want your significant digits, so I've got 3 significant digits here, so this will come out to 11.6 feet. Whew. Okay, so those were kind of a good breadth of problems. So you really have to, like, draw out the situation, find that right triangle, and then try to figure out which trig function matches the situation. So it's just a little bit of practice. If this was helpful, consider leaving the video a like or a comment or sharing it with a friend or subscribing. And otherwise, thanks for watching, guys. I'll catch you next time.